Welcome to video 4 of the Algebra I Final Exam Test Prep. This video explains how to solve problems 31 through 40 of your practice exam. Please reference videos 1, 2, 3, and 5 to view solutions to the remaining practice test questions. A copy of this practice exam is located in your course in Blackboard. Question 31. Multiply. Leave the answer in factored form. I have two rational expressions and I'm asked to multiply them together. In order to multiply rational expressions, we just multiply the numerators together and then the denominators together. So my first numerator is a 4x plus 1, and that's going to be multiplied to the second numerator, which is an x minus 1. Now with my denominators, I have a 4, and I'm going to multiply that by the x plus 7. Now the problem tells me to leave the answer in factored form. So right now it's in factored form, and the only thing I want to check is to make sure that I don't have any like factors on the top and bottom that I can cancel. Right now I don't have any like factors, so I can't cancel anything. So this is going to be my final answer since it's in factored form, and this corresponds to choice B. Question 32. Divide, and if possible, simplify. I'm asked to divide two rational expressions. To divide rational expressions, you keep the first expression, change the division sign to a multiplication sign, and then flip the second expression. So I'm going to do that now. I'm going to keep the first rational expression. Then I am going to change the division sign to a multiplication sign. And lastly, I'm going to flip the second expression. So what was once on the denominator is now in the numerator. And what was in the numerator is now in the denominator. Now that this is a multiplication problem, I can just multiply the numerators together and then the denominators together. So everything that you see on top is going to stay on top, and everything you see on the bottom is going to stay on the bottom. So in order to simplify this, I need to factor out all these quadratic equations. So I'm going to start with the first quadratic that I see in the numerator position, which is the z squared plus 12z plus 36. I'm going to factor that into two sets of binomials. To do that, you first look at the first term, which is z squared. I know that z times z gives me z squared, so that will go in the first position of my parentheses. Now to find the value in the second position of the parentheses, you look at the last term, which is a positive 36. And we're going to list the factors of 36. We have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Now I'm going to figure out which set of factors to choose. To do that, you look at the middle term of the quadratic, which is a 12, and you'll identify the factors that when added together give you a 12. Well, the factors 6 and 6 add up to give me 12, so those are the numbers I'm going to choose to go in the second position of each parenthesis. Now, like we said before, we want a positive 36, and when we add up the 6's, we want them to be a positive 12. So that means that both of my signs are going to be plus. Now that I factored that numerator, I'm going to go on to the next numerator and factor that into two sets. Same thing, you look at the first term, which is a z squared. Z times z will give me a z squared. Next, I'm going to look at the last value, which is a 35, and list the factors of 35. I have 1 times 35 and 5 times 7. I want to choose the two factors that I can combine to get a positive 2. So I'll choose a 7 and the 5. Now in order to get that positive 2, I'm going to take a positive 7 and subtract 5 from it, since a positive 7 minus 5 will give me that positive 2 in the middle. Now that I have those two factors, I'm going to move on to my denominators, and I'll look at the z squared plus 13z plus 32. Again, you'll just set up your two parentheses and factor. The z squared is factored into z times z. Then the 42, we'll list the factors of 42, which are 1 times 42, 2 times 21, 3 times 14, and 6 times 7. Now I'm going to choose the two factors that when combined will give me a positive 13. This will be the 6 and the 7 because 6 plus 7 is 13. So I have a 6 and a 7. Since I'm multiplying those numbers together to give me a positive 42 and I'm adding them to get a positive 13, both of these signs will be plus signs. The last thing I'm going to factor is the denominator, z squared plus 6z. This one's a little different because there's two terms and both terms have a z in common. So I'm going to factor out the common factor of z. When I do that, I'm left with a z plus 6 within parentheses. Now, like I said before, since this is a multiplication problem, that means that all of the numerators will stay on top and then all of the denominators will stay on the bottom. So I'm just going to draw a big bar here just to let myself know that all those numerators are staying on the top and all the denominators are being multiplied together on the bottom. The last step is to look at the top and bottom of the expression and cancel out like terms. So I have a z plus 6 on top and a z plus 6 on bottom that I'll cancel out. I have another z plus 6 on top and another z plus 6 on the bottom that I'll cancel. And also I have a z plus 7 on top and a z plus 7 on the bottom, and I'll cancel that. Now that I canceled the like terms, I'm going to write what I have left over. On the numerator, I have a z minus 5, and in the denominator, I have a z. I can't cancel any other like terms, so this is my final simplified answer, z minus 5 divided by z, and this corresponds to choice A. Question 33. Perform the indicated operation and simplify if possible. Here I'm being asked to add two rational expressions. In order to add two rational expressions, I need to have the same denominator. So the first step is to look at our denominators. The first denominator is an x squared plus 14x plus 49. The second denominator is also an x squared plus 14x plus 49. So these denominators are the same. Since they're the same, that means that we can add the numerators together and place them over the denominator. So I'll write my my common denominator, which is the x squared plus 14x plus 49. That will stay on the bottom. And then I'll just combine the top values together. So I'm adding the x squared minus 11x to the 10x minus 56. Now all I need to do is simplify the numerator by combining the middle terms. So a negative 11x plus 10x gives me a negative x. Now I'm left with x squared minus x minus 56 divided by x squared plus 14x plus 49. Now that I added the two expressions together, I'm going to simplify this answer. To do that, we want to factor the numerator and factor the denominator and then cancel out any like terms. So I'll factor the numerator into two sets of binomials. We'll look at the first term, which is an x squared. I know that x times x gives me x squared, so that's in my first position. Then I look at the last term, which is a 56, and I'll list the factors of 56. We have 1 times 56, 2 times 28, 4 times 14, and 7 times 8. Now we'll look at the middle term, and I want to combine the factors in a way that gives me a negative 1. So I can combine the 8 and the 7 to give me a negative 1. In order for that to happen, I need a negative 8 and a positive 7, and I'll get that negative 1. So in one parenthesis, I'll put a negative 8, and in the other, I'll put a positive 7. Now I need to factor the denominator into two sets of parentheses. I'll look at the first term. X times x will give me x squared. Now look at the last term, which is a 49. The factors of 49 are 1 times 49 and 7 times 7. My middle term is a positive 14, so I want to choose two factors that when combined will give me a positive 14. That's going to be the 7 and the 7. If I add a positive 7 plus 7 together, I get a positive 14. So my factors are a plus 7 and a plus 7. Now that I factored the numerator and denominator, I'm going to cancel like factors. I have an x plus 7 on top and an x plus 7 on the bottom. That will cancel out. And I'm left with an x minus 8 over x plus 7. X minus 8 over x plus 7 cannot be reduced any further, so this is my final answer. And that corresponds to choice D. The first step is to subtract or add these expressions. So if we look at our first group of parentheses, the x over 6 minus 3 over x, I need to subtract those two fractions. They have different denominators. So in order to subtract them, I need to have the same denominator. Now the least common denominator is found by multiplying the 6 and the x together. So that tells me that the LCD of the first set of parentheses is a 6x. Okay, so I want to rewrite the subtraction problem so that the denominator is a 6x in both fractions. If I look at the first fraction, x over 6, I'm going to ask myself what I have to do to make the denominator 6x. Well, if I have x over 6, I need to multiply the bottom by an x in order to get the 6x in the denominator. So whatever I do to the bottom, I have to do to the top. So that means I'm going to multiply the x over 6 by x over x. Now with the 3 over x, I'm going to multiply the top and bottom by a 6 over 6 because that will give me the 6x in the denominator. If I do that, I get an x squared over 6x for my first fraction, and I get a 18 over 6x for my second fraction. Now that they have the same denominator, I can subtract the numerators, so this leaves me with an x squared minus 18, and then I keep the denominator, which is a 6x. Alright, I just subtracted this first set of fractions. Now I'm going to add this second set of fractions, which is the 3 over x plus 1 over 2. Now the same thing, when I add fractions, I have to have the same denominator. I have an x in one denominator and a 2 in the other denominator. So that means that the least common denominator is a 2x. So I have to rewrite each of these fractions so that the denominator is a 2x. Alright, in order to do that, I have the 3 over x. In order to get a 2x in the denominator for this one, I need to multiply the top and bottom by a 2. Then for the second fraction, I have a 1 over 2. In order to get a 2x in the denominator, I have to multiply the top and bottom by x. So if I look at the 3 over x times 2 over 2, I get 6 over 2x when I multiply that out. And then I'm adding it to the 1 over 2 times x over x, and when I multiply that out, I get an x over 2x. Now that these fractions have the same denominator, I can keep the denominator, which is a 2x, and add the numerators, which gives me a 6 plus x, or an x plus 6. Now I have two expressions that I'm going to divide. In order to divide, I need to rewrite this as a multiplication problem. So I'm going to keep the first expression, change the division sign to a multiplication sign, and flip the second. Now I'm going to multiply the two expressions by multiplying the numerators together and then multiplying the denominators together. So I just keep all the expressions on top that are on the top, and I keep all the expressions on the bottom. Lastly, I need to see if any of these factors can cancel out. Now if we look at each of these factors, they're all in simplified form. I can't factor them any further. So I'm searching for factors that are alike on the top and bottom. Here I have a 2x and a 6x. The 2 and the 6 don't cancel out, but they can be reduced. If we look at this fraction 2 over 6, I can divide both of these evenly by 2. So it leaves me with a 1 on top and a 3 on the bottom. So I'm going to cancel out that 6 and rewrite a 3 there. The next factor that will cancel out are the x's, the x on top and the x on the bottom. And that's all that I can factor. So to write my final answer, I have what's left in the numerator, which is an x squared minus 18. And in the denominator, we have a 3 times the 6 plus x. Now our multiple choice answers are not in factored form. So that means I'm going to multiply or distribute the 3 to each of the terms in parentheses in the denominator position. And that will give me an answer that is a choice in our problem. So I still have that x squared minus 18 as the numerator, and then the 3 times the 6 gives me an 18, and the 3 times the x gives me a positive 3x. And we usually write our x terms first. So that means if I look at my denominator, I'm just going to rewrite this as a 3x plus 18. And I can do that since we're just adding those terms together. And this is my final answer, and that answer corresponds to choice B up in our multiple choice problem here. Question 35. Solve. If no solution exists, state this. Here we have two rational expressions, and they're equaling one another. When we have this kind of setup, we can solve this by multiplying by the denominators. So we'll write out our problem. We have 4 over x minus 9 equals 1 over x plus 5. So I'm going to get rid of the denominators by multiplying them on each side of the equal sign. So here I'll multiply it by an x minus 9, and I'm going to do this on both sides. Now on the left side, this gets rid of the x minus 9 factor in the denominator, so I'm just left with a 4. Now on the right side, I have 1 over x plus 5 times x minus 9. To multiply, I'm just going to multiply the top factors together and the bottom factors together. So I'm left with 4 equals an x minus 9 over x plus 5. Now I need to get rid of the x plus 5 term, or factor. So I'm going to multiply both sides by the x plus 5, and that will cancel on the right side, and it will leave me with just an x minus 9. And then on the left side, I have x plus 5 times 4. So I'm going to distribute the 4 to each term in parentheses. This leaves me with a 4x plus 20. Now I have something that's very manageable. To solve this, I'm going to get all my x's on one side and all my numbers on the other side. So I'll subtract x on both sides. This will leave me with a 3x plus 20 equals a negative 9. Now I'm going to subtract 20 from both sides. Again, I'm just working on isolating my x term. Negative 9 minus 20 is a negative 29. Lastly, I'll divide both sides by 3, and I'm left with x equals negative 29 thirds. If we go up to our original problem, we'll see that negative 29 thirds is choice C. Question 36. On a map, the length of a nature center trail is 11 centimeters. If the scale is 2 centimeters to 19 kilometers, what is the actual length of the trail? Round your answer to the nearest tenth if necessary. To solve this problem, we're going to set up a proportion. We're told that the scale is 2 centimeters to 19 kilometers. This is going to be my ratio, and my numerator is going to be the length on the map, and the denominator is going to be the length of the actual trail. So in other words, I have centimeters on top and kilometers on the bottom. I'll set this ratio equal to another ratio, which has the length of the trail on the map, which is 11 centimeters, over the actual length of the trail in kilometers. That's the value I'm looking for, so I'm going to call that x. And again, my centimeters are going to be in the numerator position, and my kilometers are going to be in the denominator position. Now that I have my proportions set up, I'm just going to cross multiply and solve for x. So 2 times x is 2x. And that equals 19 times 11. And 19 times 11 is 209. Lastly, I'll divide by 2 to isolate the x. So I get x equals 209 divided by 2, which is 104.5. And this is in kilometers. That's the actual length of the trail, and this corresponds to choice A. Question 37. Determine whether the ordered pair is a solution of the system of equations. Use alphabetical order of the variables. For this problem, I'm given an ordered pair, which is 4, 5. The problem tells me to use alphabetical order of the variables. So that means that 4 is going to be my A value, and 5 is going to be my B value. To determine whether or not the ordered pair is a solution to this system, I have to plug in the 4 and 5 into both equations. If this ordered pair is true for both equations, then it is a solution to the system. So first I'm going to take the 4 and the 5 and plug it in to the top equation, which is b plus 4a equals 11. Again, b is 5 and a is 4, so I have 5 plus 4 times 4, and I want to see if it equals 11. 5 plus 16. 5 plus 16 is 21, and 21 does not equal 11. So this is a false statement. And that tells me that this ordered pair is not a solution to this equation. Since it's not a solution to this equation, it can't be a solution to the system. So it's automatically no. as our answer. But if you wanted to, you could also plug the 4 and the 5 into the second equation. We'd also get a false statement, and so that would further clarify that that ordered pair is not a solution to the system. Question 38. Solve the system of equations by graphing. If there is no solution or an infinite number of solutions, state this. To solve this problem, I'm going to find two ordered pairs for each equation and then plot those ordered pairs to make a line. Once I have two lines plotted on the graph that represent each equation, the point of intersection is going to be my solution for the system. So first we're going to look at the top equation, which is 2x plus y equals negative 14. And I want to find two xy ordered pairs that I can easily plot on a graph. Now if you'll notice in this equation, the y is by itself. So I'm going to solve for y. And this will just ensure that I get whole numbers when I go to plug in an x or a y to find ordered pairs. I rewrote the equation to be y equals negative 2x minus 14. Now I'm going to create an xy chart and just find 2 points so I can plot them on the graph and draw the line. In this case, I'm going to plug in values for x and then solve for y. So you can choose any values for x that you want. I'm going to choose 0 and also a negative 2. And again, you can choose x equals 1, x equals 2. It really doesn't matter. I'm just going to choose a negative number so I get a lower value for y, so it's easy to plot on the graph. Okay, when I plug in a 0 in for x, I get negative 2 times 0 minus 14. So that gives me 0 minus 14, which means that y is a negative 14. My xy ordered pair is 0, negative 14. I'll do the same with a negative 2. I have a negative 2 times a negative 2 minus 14. Negative 2 times negative 2 is a positive 4. So positive 4 minus 14 will give you a negative 10. So my next ordered pair is a negative 2, negative 10. Now what I would typically do is I would go to my graph and plot those points and make the line. But for the sake of space on my whiteboard, I'm going to go ahead and find ordered pairs for the second equation, and then we'll plot both lines together on the next slide. The second equation is x plus 5y equals a negative 34. If you'll notice, the x is now by itself. So it's going to be easier to isolate the x by subtracting the 5y on both sides. And now I'm left with x equals a negative 5y minus 34. So now with this equation, since I have x equals, I'm going to plug in values for y and solve for x. So we're doing the same process, but we're just solving it backwards. Okay, so just like before, I'm going to create the xy chart. And now I'm going to choose values for y. So I have some pretty big numbers in this equation. and I want to be able to plot them all on a single graph, and usually the graphs don't go up that high for the x and y coordinates. So I'm going to choose a -5 for y and also a -6 for y. And this will give me a little bit lower x, so I can plot the ordered pairs easily on the graph. All right, so I have x equals a -5 times y. I'm going to plug in a -5 minus 34. This gives me x equals a positive 25 minus 34, which is a -9. So x equals -9. So I'll put in a -9 here. And that means that my xy ordered pair is -9, -5. Now I'm going to plug in a -6 for y. So I have x equals -5 times -6 minus 34. A -5 times -6 is a positive 30, so x equals 30 minus 34. And that gives me x equaling -4. So my value for x is a -4 when I plug in a -6 for y. And that ordered pair is now -4, -6. Now I'm going to go to my second slide and plot the points for the first equation on the graph and make a line. Then I'll plot the points for the second equation on the graph and make a line. And then I'll identify the point at which the two lines intersect, and that will be my answer. Okay, so here's my graph, and my first line, I found that it contains points 0, -14, and -2, -10. So first plot 0, -14. So that means my point is on the y-axis right there. Then I have point -2, -10. So I'll go to the left 2 and down 10. And that gives me a point right here. Once you have 2 points, you can connect the dots to make a line. Please excuse my line, it's a little wiggly, but it is supposed to be a complete straight line through those points. And you can always make more points by using the same method as we did before and extend your line a little further. Now I'm going to graph the second line, which is -9, -5, and also point -4, -6. So -9, -5 will go to the left -9 and down -5. So that puts me about here. And then -4, -6. I go to the left -4 and down -6. And that puts me right here. And as you can see, it puts me right on that blue line. So automatically I know that it intersects at -4, -6. I went ahead and drew the second line anyways, and you can see that those two lines only intersect at one point. And that one point, like we already said, is -4, -6. That's the solution to our problem, and that solution corresponds to letter C in the multiple choice area. Question 39. Solve the system using the substitution method. If the system has no solution or an infinite number of solutions, state this. We have two equations and we want to use the substitution method. The substitution method tells us to solve one equation for a variable and then take that expression and plug it in for the variable in the second equation. If we look at the top equation, we have what y equals. It's in terms of y. This equation is telling us that y equals 4x minus 1. So I'm going to take that expression 4x minus 1 and plug it into y in my second equation and then solve for x. So here we have 4x minus 1 minus 4x equals 2. If I take this out of the parentheses, I get 4x minus 1 minus 4x equals 2, and I combine like terms. I have a positive 4x and a negative 4x. These cancel out, so my x terms go away, and I'm left with a negative 1 equals 2. This statement is false since negative 1 does not equal 2. Since this is a false statement, my conclusion is no solution. And that is choice C. Question 40. The owner of Nuts to You Snack Shack mixes cashews worth $5.50 a pound with peanuts worth $2.20 a pound to get a half-pound mixed nut bag worth $1.90. How much of each kind of nut is included in the mixed bag? To solve this question, I need to create a system of equations and then solve for two variables. First, I'm going to assign my variables. If we look at this question, we're dealing with two different kinds of nuts. We have cashews and peanuts. I'm going to let x be the amount of cashews, and I'll let y be the amount of peanuts. Now I'm told that cashews are worth $5.50 a pound. So we'll make note of that. And then peanuts are worth $2.20 a pound. Lastly, I'm told that a half-pound mixture is worth $1.90. My first equation is going to deal with the monetary amount. So instead of $5.50, I'm just going to call this 5.5. And this is how much the cashews are a pound. So 5.5 times x plus 2.2 times y will give me an amount of $1.90, which is 1.9. That's my first equation. My second equation is going to deal with the weights. This will be x plus y equals half a pound, or 0.5. And that's because I'm told that the mixture of cashews and peanuts together equal half a pound to get that mixed bag worth $1.90. Alright, so these are my two equations. To solve, I'm going to use the substitution method. You could use the elimination method if you want, but I think the substitution method will be a little bit easier. So I'm going to choose the second equation, x plus y equals 0.5, and I'll solve for y. So I'll subtract x on both sides, and I get y equals negative x plus 0.5. Now I'm going to take that expression for y and plug it into the top equation and solve for x. So I have 5.5x plus 2.2 times negative x plus 0.5 equals 1.9. Now I'll distribute the 2.2 to each term in parentheses. I have 5.5x minus a 2.2x because I multiplied by a negative x here, so that gives me a minus sign in front of the 2.2. And then 2.2 times a 0.5 gives me a 1.1. And this is a positive 1.1. Now I'll combine like terms on the left side of my equation. I have a positive 5.5x and a negative 2.2x. So 5.5 minus 2.2 gives me a positive 3.3x. And I still have that plus 1.1 on this side. And then that equals a 1.9. Now I'll subtract 1.1 on both sides of the equal sign. And we have 3.3x equals 0.8. To solve for x, we just need to divide both sides by 3.3. X equals 0.8 divided by 3.3. We'll do this on the calculator and we get x equals 0.242424, repeating. And if we round to 3 decimal places, we get that x is approximately 0.242 pounds. Now that we have what x equals, I can plug that value into my second equation and solve for y. My second equation is x plus y equals 0.5. I know that x is the 0.242, so I'll substitute that in. Then I'll subtract that value on both sides of the equal sign. And y equals 0.5 minus 0.242, and that's an approximate value of 0.258. So peanuts is 0.258 pounds, and the amount of cashews, which is x, is 0.242 pounds. If we go back and look at the answer choices, we can see that these answers correspond to letter B. So B is going to be our correct answer.